which is tricky to deal with.
Okay, so I hope everyone can hear what's online. Yes. So I will go very, this was asked from the online, I will go very quickly through the next one notebook, but the aim is for you to try any kind of notebook that you might be interested in, because otherwise it's boring if I go through each step. So I will just go through the notebook that I have run already, so I will directly show you the outputs and explain what's happening.
Okay.
Sorry, yes, I need to present. Thanks.
I don't know if you are.
Okay, maybe I will, yes. And I need to use that microphone, right?
Which is the
Okay. Someone has the question.
I use the option one. So this one is paid, the other one? The option.
Okay.
Yeah.
Now, is it sharing on
Yeah.
Yes. Yes. So I remind you that it was timing mode. So this is a special mode. So in case you work with imaging mode, then this is not for you, but you can follow the other threads. So the way you start, as usual, you import all of your libraries. I will not go into the details, but here I imported the libraries of interest that I have for my analysis. I work with DXA and JAXPEC, so I also imported them here. So that's the SAS startup. And here you can see my output that I successfully run them. And here libraries again. Then here I defined the path for the calibration files that you have under the data folder that is linked to your data volumes here that you have on the top right corner. So in case there is a problem, just unmount them and mount them again. Don't worry, if you have unmounted them, you will have an error showing that it cannot locate the calibration files. So you just mount the data volume. Then you start SAS. Here you define your work working directory, and here you have the Swift build or the Diez ingest with all the corresponding outputs. And now it's time to run epproc. So here you have just a few, maybe a bit more complete than the other threads, just a few sanity checks that will just tell you you already have run in the past epproc. Do you still want to do it? Do I erase the previous files? Sometimes if you run again your Jupyter notebook, you may not want to rerun epproc every time. So you can customize sanity checks. Yes, and then here I run fselect to have access to the first image of the source. So here we have this image of the timing mode that I mentioned earlier and I showed during the presentation. So we check for flaring particle background. And as I told, so here just I'm not going into the details of the lines of codes. You can see them in the notebooks directly. So here I chose the patterns that I'm interested in, the different energy bands, etc. And here, using LCVs, I plotted the light curve with the threshold that is suggested by the thread for flaring particle background. And as I said before, my whole source, my whole observation is above the threshold. So I will not filter it because it's just that it's very bright. But see, here you have, using LCVs, you have this nice interactive command. So you can here you can zoom in with your mouse as well if it works. Yes, supposed to work. Yes, here you can zoom in. My mouse is broken. Yes, you can zoom in, go back to how it was before, and you can see the value of each point. That can be interesting. Yes. So once we check, in my case, that we don't need to filter for particle background, For flaring particles, sorry, we also check for the background, but as I told you before, also in the background, my light curve is way above the threshold just because the source is too bright. So I added a keyword, filter for flaring particles background. I said no, because the source is too bright, but you can change it to yes. I tried to make the notebook in such a way that if you have different settings than I have, and you have another observation in timing mode, you can use the same notebook for another source. The barycentric correction, if you want to correct your times, and if you want to do timing analysis. And here, the pilot path, that can be maybe interesting for you. So here again, I show the image of the observation, and using GS9, so it's not plotted here, I commented it, but here you use GS9 the same way that you used it for sources that have a annular or circular region. Here, it's just that it's going to be a rectangle. And so you open it with GS9, and then you trace your DS9 on your local laptop, and you trace your rectangle for the source and your two rectangles for the background. Or you can just choose one actually. So I could choose the center here and the background as far as possible from the maximum of the PSF. But in this case, the source is so bright that even the background is impacted by the source. So I ignored the background. And here is the source region that I selected. I decided to select this. So this is what I have left, and I am ignoring all the other columns. And here I use EPAT-plot to check if there is pileup in this observation. And as you already know, there is pileup in this observation. And I cannot show interactively in the Jupyter notebook the output of the EPAT-plot, but I know that they are somewhere over here. Yes. Yes. So here I used EPAT-plot several times. So for example, that's the way I named also in the notebook, I named the output file. Here I said, okay, I'm trying to check the EPAT-plot between row 32 and row 44. Let's see what it looks like. Okay, it doesn't look great, so I'm trying with another one. And here normally I have all of the EPAT-plot. Maybe I deleted them, but yes, if you run it every time removing the centermost column, then yeah, I don't have the EPAT-plot files for the other ones, but anyway, you remove the centermost columns, you run EPAT-plot, and then you see if your fractions they become closer to 1. So I did that basically. So here I just give you the final answer. Here I tell you that you need to extract columns between row 32 to 36 and then 40 to 44. That means I excised the 3 centermost columns. And this is what it looks like in the end. So here you can see the white part in the middle. That means those are the 3 centermost columns I decided to ignore because they were so piled up that they are just not usable. I could excise more regions. Some of my colleagues would excise more. Some of them would excise less. This is just up to you, and you just need to justify it. So when I did this analysis for my paper, I just said this is what I decided to do, and then I justified, of course, why. But you have the right to choose something else. So here we mentioned it also this morning, the rate-dependent energy scale effects in PM timing mode. So as I said, you may see a shift, at least from the scientific point of view. That's how I saw it in the online. I saw there was a difference of 200 electron volts. So I followed the threads on the XMM stats website, where there is a thread that tells you need to check for those aspects as well. So the way that it works, you just extract the spectrum the way it is. So that means the spectrum for these columns that I decided to keep. And I look at the spectrum. I look at the spectrum here. Don't worry about the commands, that those are just the lines to get to the spectrum. And what you do is that you fit a very simple model to your data. So here I decided to, problem is that VLX1 is not that simple, that simple power law is enough. So I went for a partially absorbed power law continuum, but you can do whatever you want, as long as it defines more or less correctly your continuum. So this is what it looks like here, and that's the spectrum with the simple model. And then you go to the 3 instrumental edges that are written in the thread. So there are 3 of them, and they are, where did I write them? Here, at 1.8 keV, 2.2 keV, and 11.9 keV. So they correspond to gold, and I don't know, silicon, and then something else. I don't remember which one. So you check at these 3 edges what happens to your spectrum. So here I show it here, what 1.8, 2.2. The problem for the 1.8 is that it ended up in the region of the spectrum where I have emission lines on top of the edges. So it was very difficult to see if there was a shift. So I decided to ignore this edge. But for example, at 2.2, we can see that the model is a bit offset compared to the data. So I measured the offsets that there was between the two. And so for that, you use a gain, and with XSpec, you can do that. And then I saw that it was slightly better, and I measured the shift here where I print the value of this amount of electron volt. And then I did the same at 11.9 keV, and here it's a bit more obvious because this effect, at least what I'm seeing here, it becomes even more prominent at higher energies. And here you can see between the simple model and the edge that there is a big offset. So then also I calculated the gain shift that there was between those two. And I saw that here it was 165 electron volts. So then you apply the command that is called F energy shift, and you need to give the value of the 3 offsets that you saw in the command. Don't worry if you have only 2, like in my case, or only 1. You need at least 1 to be able to run the command, and then it works. What it will do is that it will do a combination of those 3 values that you gave, so that, for example, at low energies, if you have a little shift, but at high energies, if you have a bigger shift, it will do an interpolation between the 3 values, and it will shift the energy of all your events accordingly to the 3 values that you gave by doing the interpolation. But that is not your problem. You just run the command, and then you check again your spectrum, and you are happy, so that means you can go ahead. Like curve. Yeah, so now that we have done all the filtering, the timing, the pile-up, and all these things, now we can finally do the science. So now I will extract the light curve only in the columns that I decided to keep for the analysis, and the spectrum only in the columns that I decided to keep for the analysis. And so here I show the light curve with the interactive LCDs, and here I do normally, here I just show another way to plot the light curve. Here I zoom in the light curve. I binned it with 1 second, and here I zoomed for, let's say, 3 pulses of the neutron star to see what kind of resolution you can achieve with ACME in timing mode. And then here I plot the, so I check the RMF, that everything looks great. I check the ARF, that it is okay. And then I show here the spectrum of the observation. And here I've done it also in an interactive way, so you can zoom in. So here it's the beautiful iron line, and here we can see that I find it at 6.42 kilo electron volt, but before the correction for the energy that I showed you before, it was more at 6.6 kilo electron volt. So that's how I realized there might be an issue. But this one is not easy to spot. You need to have a good idea of your spectrum to know if there is a shift or not. In my case, I had simultaneous data, so that was easier to see that there was a disagreement between the instruments. And then you can use GTIs, as I showed during my presentation. So I decided to use 3 t-start and 3 t-stops. So I decided to cut the observation in 3 parts. And so here I give something, but you can give whatever you want to do. For example, in my analysis, I actually extracted 1 spectrum for each pulse of the neutron star. So that means I extracted 1 spectrum every 200 something seconds. I had several hundreds of spectra for the same observation. So you can do what you want with what makes sense scientifically. And then you can extract the spectra accordingly. So you can do a loop, and you can say, please go through all of my GTI files that you need to create. It's a simple file, fixed file that has t-start and stop. And then you say, go through all of my GTI files and extract me a spectrum every time you use a new GTI file. So you can do that in your Jupyter notebook. And then you can plot it. And this is what it looks like. And with this plot, you can see how variable was the source during the observation. So I think green was at the beginning of the observation and blue was at the end of the observation. So that shows how much the spectrum has evolved during the observation. And I think that's it. Yes, that's it. So I went a bit fast, but like if you are interested in timing mode, just run the notebook. I gave the explanations, and if something isn't clear, just ask questions. But I think it makes sense for you to try it. And yeah, and then you have the science cases of RPS also.
Now it depends on what we want to do. If you want to, I don't know, you can finish with the PKF example or not. If you can finish, I mean, you can try the Bella one, you can do it. If not, there is the RPS one. Then you can also, I mean, if you are interested in high resolution spectra, it's also a good exercise. Or if you have your source and you want to try something, please do it. Load them in your source, execute it, and if you have any error problem, ask. And then you have the right moment to ask. If you have also in the PKS one, there is a Diez. I mean, you create a spectra and you fit it with a spec. You can also try to get a feeling how to deal with by spec and how to fit it within the computer output. Because you have to disable the display to use it to be able to use it inside the network. Okay, good. Looks like a plan. First question. And I want to see the spectra. And the spectra and fit it with extra. Okay.
This on the development. Yeah, the one is that this is something that is at the very early stages on 2 years old, so we are trying to get findings. Continue the development. At the moment, if I recall correctly, if you have a table, your table is valid for more than details for the future. But we don't have so that's why if you have like very complicated spectrum individual objects, if you have less complex things, that kind of problem. Yeah, I know. Yeah, only if you have the table, you can investigate. Yes, I just correction. Yeah, yes. So like yes. Actually, it's so I was shift and yes, this is only exactly the way it is called. I always use the way the rate dependent energy state. So I'm pretty sure this is possible because I realized it when
And I saw that they had it 2 years ago.
Because we had the tool before, but it had some consolidation effects. So it was, I used it in the one, but it was not effective. It was even worse, basically. So, and then and that's why they managed to take a work because they corrected the Ibarra. So now it should work. And ideally, because it should at least only realize that during the very entire staging, it's almost very one time that this activity can work here. So ideally, actually have with the kind of dependence that I was but this is try to take a GTI and then finish the GTI for estimation to achieve the
Evaluation how I should find so
it's fine to do full observation. You will correct for maybe a sheet that appears in the average observation, but it will not be enough. Any calculation, so like so they will not they will do a little bit of low energy and a lot of high energy. Normally, you try to. I mean, if you have okay, if you have the other way around, it's fine because you need to do calculation. And for example, in my case, I have another source where I it was good because at the energy it was a positive shift and at high energy it was a negative. But in the problem, you can do even if they don't have the same sign, it will be an interpolation.
I don't understand you ever mentioned
No, no.
is it a problem?
That's reflection. About optical loading.
Optical volume for this bright sources because the reason I write a flag in the PM
Yeah, so normally at the beginning of each exposure, there is an offset, I mean, it's taken, and this offset image is used.
Oh, I have used it. Sorry.
So the problem is if you have it's very unusual. If you have several exposures where the pointing changes a bit, where you only have the offset for the first exposure, you don't have the offset one. And then you have a problem. But I have only seen this problem in mosaic, we have mosaic observation that it covers a huge field of view. And this mosaic observation, the first exposure, you have the offset, and then the observation you have the offset, and the field of view is completely different. And you have verticals. So here you see, and you can also start. So in principle, the loading is what is a problem is the out of time. There is also, so there is a threat also to correct the out of time events. And it's difficult because it's just events that goes to the data, so there is nothing you can do. But you can also.
Because I'm working with that flare star, and my question was during a flare, because also the optical brightness is constantly during the flare. So during the flare, I expect that the optical volume is rising.
Yeah, it's different.
So next question is, how we affect something that.
Maybe you can try to, not to use the offset that I'm thinking at the beginning.
Yes, so don't use
and compare it and see how different is the. At least you see that with without subtracting the offset doing the top. Scale now.
otherwise.
There is a flare within the observation, and yes, it will be affected. You have more look with the offset to check.
Between 0.1 but in many the public documentation, they say that it's not really good and reach maximum 1.5, 0.1, and that's it. What should I follow? I mean, should I trust them that it's not a good plan? Should I use it?
Unless there is something in this, I mean, law so far that you are showing that the product has
Yes.
Because it's possible that
although the calibration files goes on the
yeah.
disk what exists.
It's correct.
Yeah, right. That's why you
Yeah.
Well, you can use that.
Yeah.
See the choice. I think it's safe. Yeah, okay, that's the same.
Yeah.
Okay. That's much about
This week.
yeah. Where we
It's all right.
yeah, no.
I'm missing the corrected one.
Yes, that's,
I can put it on this.
yeah.
Here I should also see the corrected one, so the subtracted
Yeah,
background.
yeah.
So without seeing. I define the background. The background is the sort of.
Yeah. Ah. What people? Yeah, because what happens right now is the buildings are by
Okay, but it's a finding that, so it's like.
yeah, no, no, it's doesn't matter with that. That's yeah, no, I was.
Okay, try to
Yeah, you can.
okay. Yeah.
It's one I don't want to talk
Doesn't make sense.
Yeah. On the fifth, yeah. You have all the T square now, the value, so. So it's, and then you can play a little bit with the heating and expect or whatever, but that's
And they have this number somewhere. I have no idea. I don't know like that. I have no idea. Sorry.
No, it was just out of curiosity.
Yeah, no, I don't know.
the question. What did you ask?
It's I have two questions. I tried several times to run the text chain for my expressions. The problem that I noticed that when I had it, I was never able to reproduce sources that I get.
Yeah.
And the second problem was that yes, these arrays for the source that is different source of the reference, but the effect chain is just position except groups of the sources.
No.
Am I missing something?
No. I mean, it is important for anyone in the world to reproduce the although 95% is just substance. There is 5% which is utilization of the signature. And especially, yeah, it's carbon that they do with me and that is impossible. I mean, you can go to the event file, and in the event file, in the pitch file, you have all the expression and calculation.
Yes, of course. Just a second, I'm running comment. You can come.
Yes, and then I know that my use because they have an inside the
Okay, let's see.
Here I'm trying to fetch another. I got this error that doesn't exist. So
I mean, you will never get it, but at least you basically impact the select the size of the source is even for but I know in the chain it has fixed.
I just changed the upside down. If I go
No, in fact, I abandoned it because I'm subtracting. I'm automatically subtracting with the Diez. So I was trying to do it with my machine, but it was impossible. So I'm going instead. Yes.
I know that we don't use it,
So I need to read my myself if I would not figure the process.
does it mean that it doesn't exist?
Did you check that this upside is right here?
I mean, I did it before manually. I inserted XMM master
So I was wondering if it's needed
for observations on sources of I find this one. Maybe
Okay, let's see. I would
Try to check that
you're trying to get the outside into this.
Yeah, I'm checking it. Yeah. Also, sorry. I was checking also the other.
Oh,
Yeah.
I like that.
I expected the larger of the source, one of the diagram, and then when I try to do the correct one.
The figure secret. Yeah.
No.
I don't know.
And then when I
Doesn't exist.
non-zero,
Magari era questo.
I don't know why.
I'm not sure because maybe it doesn't look. Voilà, that's. I was not in the box.
5-2-0, 5-0, 2-0.
No, it exists. But I think I see the problem. You need to put a 0 for because the XMM upside here they use this actually. So find the 0. Yeah, put the 0 in front.
No.
Oh, okay.
Now it works.
Maybe you can show bigger settings. I don't know.
Okay, could be a problem.
Yeah. The question. Yeah, download.
Okay, perfect. Nice.
I searched in the folder and there is
There is the profile.
no. There is because the maybe
The price of it doesn't say.
no, no, this is the correction.
No,
Oh, it's open. Okay, here, XML 01, 01, yeah, and then analysis. Not producing the corrective.
And so we need to see the practice. No. So this part is. You know, I did the first one.
Yes, just 1 second. Sorry. I will try to. I got it. Yes.
Yes.
Is there a way to download entire directory? Is there a way to download entire directory?
In your local, yes, which folder would you like to download, for example? No, I think it cannot. I just did it 2 seconds ago, but I think maybe not the directories. Let me check.
I could download.
No, I think you need to download the maybe they have another way to yeah, it's simply because it's the same also when you want to copy a folder, you can do it via the terminal command, but like for example here, if I want to copy a whole folder in another folder, I cannot. Like here, it is not possible. So, but you can do it via the terminal to use an entire folder to copy if you manage. I don't know if you could get if you can the way you get here. No, because it will go there. No, I don't think you can. Yeah. No, I think you have to. But you can do it at the like you can select several at the same time and you can so yeah. It's annoying because you have folders. That becomes still annoying, but you can select several at the same time and like, for example here it's supposed to download. It will download everything. So that's download yeah, but I know that in the past there is there's a reason for that. I don't remember which one, but there's a reason. But maybe in the head, someone already asked the question. The way I do it is that
With more comments, it could be.
I think I would select several files and download them outside because usually also on your laptop, I imagine you would download the output files, so they're not so. You don't need to download all the calibration files. That's how yes, of course.
Regarding the regional selection criteria, like the stores and so on, do you have any recommendations? For this case, I manage the other source, but it's
Which source is it? This one?
which is really
Okay. Yeah, so you have, I mean, there's no right or wrong answer. So, for example, here, you can select, I think I would go even a bit further because the one here in this region, you have,
okay, you're just
yes, so your background will be impacted, so you can reduce the size of the background. I know that in the ideal world, the size of the background is nice if it is the same as the source. It is always better, but sometimes you have sources that are so bright that you have to modify. For example, here, if you get slightly too close, you will be impacted by this ray of light. So you need to get and then not too close from the edges because you have also like issues on the edges of the, so yeah, there's no right or wrong answer.
In this case, this could be the best choice.
I think what I do, and here I see something appearing here, you may know, out of time events. Have you checked for that? Like here, this line here, it's typical for out of time events. So what happens, even if you are in imaging mode, you can still register, detect, photons, but you have a thread about this actually. Because I see it by eye, that an effect. So I suggest you to look at into this one out of time events. So here you have a little description of what it does on the detector, but basically this is what you have. You have like a line when the detector for each frame will say the event. It will when it will go to another frame, it will keep some events that will not have time that will stay on the detector, let's say. So at each frame, it will keep them, and then it will return up to the detector. And you have a way with this thread to get rid of that. And by eye, I see that with on your source. The effects that it can have.
So I guess the light curve.
Yeah, maybe there's yeah, that's possible because like here they say photons are not only registered during the actual interaction interval but also during the readout. This is called out of time events, and they are assigned incorrect Y values leading to a wrong energy correction. And then it can create, I think they show some plots of what it can do. The effect of out of time events on spectra. So, Jacob and I should compare together with the spectrum.
Sometimes.
Yes, okay. So in green and black, you see the difference between the. It's not so good using this very bad quality picture, but you get my point. And the way you see is on the image, you see this line that it makes sense. I see it on your picture. It's super easy. You just tell in this thread, you will have to vary. This is the command that you use, and you just need to tell where it is. So what you could do, you could delete events in this column. Because I have an example. So I had it for a source and show you the slide. Where is my I have it for ancestral binary. So it's I know it's not on this laptop, of course.
So you were using this one.
I was using this one.
No, anyway, because I'm wasting my time. So basically, what you can go back to your image, image of the source, and yeah, when you will
do the image after the correction, but
Also, people then
Yes.
share the
yes, we need to ensure for
Okay,
that. And I think it is in the threads.
Yeah, so regulated speech.
Data market threads. Yes, you should see yes, more complex analysis for bright sources. Here you have 3 checks to do. Out of time events, which is the first one. Out of time events, pilot, and energy scale dependent effect. So today I just mentioned those 2 because this one is only in the image mode.
which one? Which
Sorry, today I showed only the pilot and the energy scale effects because this is those 2 they affect the timing mode and out of time events. And today, since I didn't mention imaging mode, and here you have the task and everything you what to do. So you just do select, you create the normal image, then on your image you will see this as I saw on your picture. And then you do this command, which is just 1 line, and then you need to put the numbers to put, and then it will correct, and then you will start your image again. You will have
and just about
and then you do the source region in the background. Because this is also annoying if you select the background, but in this region, you will take also the I think it only affects like maybe 5 or 6%. It's not more than if you don't do the correction, it's not right. If you don't have pilot, it's better to correct.
I really want to check.
Yeah, just you can come. Just 1 second. I'm replying to someone's question. You can sit here. There is a. Okay, and I will reply.
But then, when I go here, in my workspace, I see
I don't know.
and if I try to no, don't worry. I thought it and I see especially the way I do it, but I still do the design. So yes, I'm not very familiar with design, but I double click and let you say, and then you have a space.
This okay, your data, but in your so in your workspace.
Yeah, here.
You go to
Okay, yeah.
I see the X file. And but you have something in data.
Yes, because I before the coffee break I ran the Diez. Yeah, probably. Actually, maybe. So I use the folder data, but I cannot find this so that we have it. Then say apply. So I have the point. Ignore. Okay.
No, they here, and it has something. So why don't you say
You are here, okay, let's try
and it's you?
not the first one, take the first. Yes. Let's see. Okay. And try to.
And how do you? So don't ask me why. So your directory, why? I mean, you didn't do anything wrong, but you didn't have the execution permission. You know this Linux permission. You know what it is? Read, write, and execution. Execution for the user. The next three is for the group, and the next three is for others. So I don't know why, because I saw that the data was here. I said, okay, let's and Linux, the command change mode can add and remove. I said, I don't know why. So let me try to.
Is there a specific reason why
Quota, sí. Vale. I have another problem that is your quota.
I think
Now you have to remove some.
I thought because and then you could
Why you want to remove?
Sí,
pero have you uploaded the or no?
No. No, yeah, because there's no one. You were going to talk Okay, let's ask Aitor.
Yeah, vale. So you copy the look,
Yeah, just go back.
So there's you can delete only the pub, which is the one that contains the and that
How do you say the region JS9? Because I double click on space, but it doesn't start. I don't know for JS9.
I can try
Anche me, ho parlato una ragione del background più grande dello schermo. Non me lo diceva, solo che lui mi ha detto ma volte
No, this is to visual. So first you log this one, you log the next command, you log your image.
Okay, so I go with this.
And then you log your image, and now you get, you use this function that is in the tools directory to retrieve the information from the region that you use.
Okay.
And it's empty.
Okay. Is that correct?
No.
Yeah.
Because you log the image and then you go
So I reselect it. And I have to save it again or not?
No. And they go down and click on the get regions. And now you have this source.
Okay, so it's great.
And then you have to define the background region So you have both.
Okay, so
Select another one.
somewhere.
No, let's change it's normally better if you choose the backend ledger in the Swift.
Okay, so you do okay, so I can make it very small.
No, not very small because we need the signal to rise has to be bigger than the background ledger. You have to be, and you have to scan the
Okay, so
but everybody trying to avoid any short.
can I go over to the line like this?
No, the line you
Okay.
see, with the right, we didn't know what we so what I will do. I will first. I will split the out of time event. This is split here. Against the display the show. So this one is a right. With the readout, you have events coming from the screen. Pixel. So yeah, I will skip this. I will skip this picture there. This right pixel here. I'm gonna show. Why not? And then I will select. You have to select the two. Green. Right, and now with the two regions selected, scroll down, and then you execute it. And now you have the source and the path.
It didn't start with the background.
Okay.
And we can rotate right, double click, background, double click, yes, sure, and then
How did you select choose?
we see.
Oh shit, okay.
And then you have the show and the background. So with this radio, background with a radio big.
No, that should be good.
So now
Thank you
very much.
Thank you. 11. Yes, see you tomorrow. See you tomorrow. You will be practicing tonight a lot. Jupyter notebook. Tomorrow I want 10 questions.
I will try to run it on my project. Most of what you have is
No, but I mean, and do you know this highlight? I mean, what that we have to calculate the limits?
highlight work.
Yes, there is there is.
That's what you say.
And you enter coordinates and you calculate the upper limits for all several missions. Rosa, Linter, Swift,
Okay, that says a lot of time. What is it?
it's in the
It's in the
yeah, in the XMM In the XMM, if you go to the archive, I mean, the XMM web, you go to the archive and scroll down. Multidimensional limit server, another.
And if there's a source, what does it do?
If there is a source, I mean, they get you enter. I mean, what is your favorite source?
GRB 221009A. No, it didn't observe that.
So any
Crap.
wow, probably.
It's not my favorite. It's my least favorite. Actually, it'd be interesting to see if you observe Gehrels.
And you have the crab, I mean, all the different observation, count rate, process times, or the slew, and the point. But it's weird because I mean, we also have crab.
What is less?
This is the slew catalog. I mean, the observation.
No. Can we try another one?
Yeah.
GW. I mean, the same. Who's better, XMM or Chandra?
Perdona. Perdona. Do you want to leave? It depends.
I don't understand how to read it.
Count rate in the 02 to 2 kb, 2 to 12. The count rate in the ratio, the exposure time, and the fluxes. In the different bands.
And the date of the observation.
And the data when it was taken. Because I know you can get a plot.
You must select the
Well, I know that you can get some, I mean, a plot with this value.
You get the light curve?
See.
Okay, if you can download the tape.
No, I meant it's this thing.
No, I didn't know.
It doesn't give the points.
I don't trust.
But I know, I mean, I know you can
One time, I
plot it.
and I put it together. Did something, and I opened it up and everything. Only.
I don't know.
You know,
I don't know why. You have this point in a plot. I mean, it's not magic. I mean, you have the date, and the index actually the date, and in the Y
I like to.
yeah.
Okay, that's good.
And if there is any detection, there was an observation.
That's nice. And okay.
There is another one. I think is,
Then highlight this one is for the upper limit. Okay.
Thank you.
Thank you.